In this homework, I'm going to work through the problems from the homework for 1-2A, so I can help you to solve these equations. So in number 1, you have x plus 13 equals 16, and this is a one-step equation. You're going to use the subtraction property of equality that says that you could subtract the same thing from both sides and your equation stays balanced. So x is 3. And number 2, again, it's another one-step equation. We have a positive 4 on the left, so I'm going to do a minus 4, and that'll cancel out, leaving me with minus x equals 12. Now, I can't have a minus x, I have to have a plus x, so I'm going to either multiply or divide by negative 1, and what that does is it swaps the signs, so x is negative 12. In number 3, this is a two-step equation, because notice that you have a constant over here, and you have a number being multiplied to the x. So whatever's being multiplied to the variable is what you're going to do last, which is your multiplication or your division. So you're going to do your addition and subtraction first. So I'm going to start by subtracting 4 from both sides. That's going to leave me with minus 3x equals 15. And now I'm going to do the opposite of multiplication, which is division. So I'll divide both sides by negative 3, and I'll get x is negative 5. Again, we have a two-step equation here. First thing I'm going to do is subtract the constant from both sides. And then I'm going to have 7x equals 21. And now the opposite of multiplication is division. So I'll multiply both sides by 7, and I'll get x equals 3. Again, whatever's attached to the x, meaning multiplied or divide, that's what's going to go last. Now we have a multi-step equation. Notice that I have an x and a constant on one side and an x and a constant on the other. So I'm going to have to move across the equal sign. First thing I'm going to do is check to see if I can simplify or if the individual sides are fully simplified, and I see that they are. The left side is fully simplified. There are no like terms to combine. The right side is fully simplified, so I'm going to work across the equal sign. Since I like the variable to end up on the left side, I'm going to subtract both sides by 5x. That's going to leave me with x minus 2 equals 10, and then I'll add 2 to both sides, and I'll get that x equals 12. Keep going here to number 6. Again, another multi-step equation. I've got 4x plus 7 on the left and 14 minus 5x on the right. I'm going to add 5x to both sides. Again, because I like the variables on the left. You can do whatever you want. 9x plus 7 equals 14. I'm going to subtract 7 from both sides, and I'm going to get 9x equals 7. Now, 9x equals 7, so now the 9 is attached to the x. It's being multiplied. The opposite of multiplication is division. So x is 7 over 9. Again, here we have another multi-step equation. This one's a little bit different, and you're going to see why. If you notice, the left side is not fully simplified, so before I start adding to both sides of my equation, I want to simplify my sides. And right now, I have a 2y and a minus 4y, which can be combined. When I combine my like terms, I get minus 2y plus 7 equals 11 minus 6y. Now again, I like my variables on the left, so I'm going to add 6y to both sides. And that's going to give me, let me kind of move over here, that's going to give me 4y plus 7 equals 11. Next, I'm going to subtract 7 from both sides. 4y equals 4, and then I'm going to divide both sides by 4, and it's going to leave me with y equals 1. Again, x minus 2 times 5x plus 5 equals 4 minus 9x. Again, I have to simplify my sides first, and I notice that I have this distributive property that I'm going to have to use here. So I'm going to distribute the 2, minus 10x minus 10 equals 4 minus 9x. Again, now I'm going to look for like terms, and I see that I have 2 of them, so that's going to equal minus 9x minus 10 equals 4 minus 9x. And now I'm going to add 9x to both sides in an attempt to get the x over to the left. But what I notice is the x's completely cancel out, leaving me with minus 10 equals 4. Now I know that this is a false statement because I know that negative 10 does not equal 4. And this means there's no real solutions or no solutions to this problem. So this is a no solution. Sometimes we write no solution as this 0 with a line through it. But basically there are no values of x that make this equation true. So we keep going. 8x minus 12 equals 2x plus 3 times 2x minus 4. I'm going to have to distribute that left side. So I'm going to have to distribute that 3. It's going to give me plus 6x minus 12. I'm going to combine my like terms on the right, and I'm going to get 8x minus 12. And then I'm going to subtract 8x from both sides. Again, all I'm trying to do is get my variables to the left. In that process, though, I realize that my variables cancel, and I get minus 12 equals minus 12. And that's a true statement. And when I get a true statement at the end like that, that means that it's all real solutions or infinitely many solutions. Okay, so infinitely many solutions or all real solutions. Okay? So everything works. Whatever I pick for x is going to work in that equation. It's going to make, the left is always going to equal the right. Then I get over here and I have 0.35x plus 0.85 times 10 minus x equals 4. Now I see that I have here, in this problem, I have decimals. And I don't like decimals. And so just like I try to avoid fractions, I try to avoid decimals. And so what I'm going to do is I know that if I multiply every single term. I've got the, the 0.35x, I've got the 0.85 times 10 minus x, and the 4. If I multiply these by 100, okay, notice what's going to happen when I do that. When I go to multiply them, and I multiply them by the 100, my decimal point is going to shift 2 places to the right, and it's going to leave me with, let me get this a little bit bigger. It's going to leave me with, let me go a little thicker. Okay, it's going to leave me with 35x plus 85 times 10 minus x. I only have to multiply it to one of the two. That's a product, so it just multiplies to the front term. And then equals 4 times 100, or 400. And I like that because I don't have to deal with decimals. You don't have to do that. You can work with the decimals, but I think it's easier to work without them, so I'm going to distribute the 85 now, and I'm going to get 850 minus 85x equals 400. I'm going to simplify my left side before I ever try to go across the equal sign. So now my sides are completely simplified. I'm going to subtract, oh, and this is 50, right? I'm going to subtract 850 from both sides. And I'm going to get minus 50x equals minus 450. And I'm going to divide both sides by minus 50. And that's going to leave me with x equals positive 9. The last few are fractions. And once again, I do the same thing. With fractions, we do not like fractions when we're doing addition and subtraction and solving. So again, I'm going to make 4 the same as 4 over 1, right? And I recognize that I have a common denominator here, or at least common denominator that I could make, which would be 24. So look what happens if I multiply all my terms by 24. So 24 and 24. What's going to end up happening is that my denominator, when I go to multiply it, my denominators are going to cancel. And that's going to leave me with 3 times 3x. And then over here, the 3 is going to cancel. It's going to be an 8. And it's going to be minus 8 times 4x. And my denominator is already 1, so nothing can cancel there. And it's going to be 24 times 4. So when I do the math, 9x minus 32x equals 96. And this is going to be a lot easier than doing the math the other way, okay? In my opinion. I'm going to, oh, no, I'm not going to do that. I don't know what I'm doing there. So I have minus 3296. So now I notice I have to combine these terms here on the left, and I'm going to end up with a minus 23x equals 96, and then I'm going to divide both sides by minus 23. So I'm going to get x equals 96 over 23. It's negative. I can also, make it a mixed number, but there's no need. Negative 96 over 23 is completely acceptable. And it made it easier than dealing with fractions. Now, I could have made them fractions, but I would much rather not. And then the last one, same concept. I'm going to get x over 5 minus x over 2 equals 3 over 1 plus 3x over 10. Any whole number I get, or integer, I'm just going to put it over 1. I'm going to figure out what my least common denominator would be here. And I notice that it's 10. If I multiply every term by 10, my denominator is going to end up canceling out. It's going to leave me with a 2 there. So 2 times x. This one's going to leave me with a 5. So minus 5 times x equals, this one, nothing's going to cancel. It's going to be a 10 times 3. And this one, the 10 will cancel, and it'll just leave me with the 3x. And now I have the same problem. It's equivalent. I'm going to be able to solve for x, but I don't have to deal with any denominators. So 2x minus 5x equals 30 plus 3x. When I combine these like terms, I'm going to get minus 3x equals 30 plus 3x. And even though right now it looks like these 3x's are going to cancel because one's positive and one's negative, don't do this math in your head. Write it out. When you write it out, you're going to see that they, in fact, do not cancel. Okay, it's minus 6x equals 30. Divide by minus 6. Notice I never skip a step. It's not worth it. When you skip steps, you start to make careless errors. And it's not worth getting the deductions and getting the answers wrong. Okay, so this is the homework assignment in full. Again, notice when you know what you're doing, it's an 11-minute homework assignment, not a big deal. At first, when you start doing these problems, remember that whenever you get your x value, you can always plug it back into the original problem and make sure that it works, okay? You really never want to assume that your answer is correct on an assessment. You want to solve for all your x's, and then with the extra time at the end, once you solve all your problems, I would go back in and plug your x into the equation, and it'll work. Now, I know these division ones are harder. These fraction ones are a little harder to plug in. These are probably the most difficult to plug in. But again, let me just show you how you'll see that it'll work. So I got that x was negative 5. So negative 5 over 5 minus negative 5 over 2 equals 3 plus 3 times negative 5 over 10. So let me work on simplifying this a little bit. This is plus plus, right? So I'm going to get, I'm going to give them all a denominator that's the same so I can combine, right? So let me just, well, negative 5 over 5 is 1, negative 1, plus 5 over 2 equals, actually, I'm not even going to simplify that. I'm going to leave it as minus 5 over 5. It's just going to be easier, okay? Equals 3 over 1 plus negative 15 over 10. Let's give them all a common denominator of 10 so that I can just kind of prove that it works, right? So this will cancel, and I'll get minus 10. This will cancel, and I'll get plus 25. This one will just be 30, and this one will be minus 15. Negative 10 plus 25 is 15, and 30 minus 15 is also 15. 15 equals 15, and it works. So again, even these harder ones, you can check them, but at a minimum, check the easy ones. Plug your x in, make sure you didn't make a careless error, make sure the answer that you got is correct.